A little
Where are you
more
based?
boring in a lockdown.
Oh yeah, it must be terrible. I mean, it's a super social city, right? This must be horrible.
Yeah, and sunny and all. So
Yeah, I
we're
mean,
just sitting in our houses, getting smart.
yeah. Los Angeles, it's not that social of a city, but we still do a lot of our outdoor stuff. But and Yuri, you're in New York, is that right?
New York. Well, right now I'm in Connecticut.
Okay, but you escaped.
Yeah.
Probably a good choice. My uncle lives there in Queens, and he actually got COVID, but didn't have a severe case. He had a high fever for just a little while. So
yeah, Queens was kind of one of the epicenters. It's Queens and then parts of Brooklyn. And
the Bronx, I heard, got hit hard, right?
It's but. Yeah, we were pretty lucky. Like the company kind of saw that, so it's coming. So we started working remotely, maybe like a week before everybody else. So that was pretty good.
Nice. Well, I guess this is our first embedding meeting, and it's been great for me so far, just because I've been, I read Ray, what you posted. That was a really good article. It was an outdated library, but the way it explained the practical use of it was interesting. And I'm so ignorant on a lot of this stuff. I never heard of pooling before. And now I have some idea of what that is and why you need it. And the BERT model is so different than, I've used Word2Vec.
Yeah.
Right? But it's completely different in a lot of ways. Yeah.
Yeah, like what you said. I mean, since then, the author has produced a series of videos as well. And I've spent a lot of last night and today watching them, so I'll share those after I can share them now, actually. And the videos are more up to date than, so he references back to the articles. And he has a really nice style as well. Like it's very approachable, and he just basically talks through like his work. I basically had the same thing that you said, is like watching it filled in a lot of gaps, but it raised a lot of questions, particularly like the conceptual side, because it's such a difference. Like you really have to, I have like quite a lot of questions that I would just be able to like spit out, that it seems that you can use these neural network approaches, these architectures, and you can dive in and pull out the embeddings and use them in the same way that you can, say, Word2Vec. And Hugging Face makes that very more approachable and standardized. And it would be, but in doing so, I just keep asking myself more questions. Like everybody talks about doing this with BERT, but why can't you do it with GPT-2, for instance? Why is that so different? And what's better? And then I think it requires an appreciation of the architecture, because everyone says, well, actually, the transformers, quite a lot, isn't a language model, and I really need to understand what that means a bit more, rather than just on a superficial level. But when it comes down to it, I want to be able to use these embeddings and fine tune them and use them in a similar way I would use Word2Vec, and I want to be secure in my understanding of it. So that's my context for it.
Interesting.
Ray, what kind of problems do you want to apply these embeddings to?
Mostly unsupervised tasks. So I've been helping some folks out and been using Word2Vec and fast text to, there's been a bunch of tweets, for instance, and people want to find, understand, say, the conversations in there around a certain topic. They've been collected around a certain political subject. So, this is just one case, and you have this mass of people interacting with these accounts, and you want to start sensibly understand what's going on there, and the scale of the information is too much for a human. So it becomes an unsupervised task there, and it becomes clustering, right? So in the past, you can take Word2Vec, you can take the word vectors, you can average them out, you can create an average for the tweet, and then you start clustering, and you've got a vector space there, and you cluster. Mm-hmm. Now, my thinking is there is, that these new models, if you fine tune, you get a language model that might be more semantically meaningful than those approaches. Say like BERT on paper, I think should be better. Maybe more represents the meaning a bit better. So that's basically, if I can clear that hurdle, that would be an achievement for me.
So you're talking about a case where they actually use BERT to find different word embeddings than word2vec, or are they just implementing word2vec in using BERT in some way?
No, it's using the hidden states in BERT to get the embeddings.
Okay, so what comes out of this then is there's a vector for each. So BERT comes up with its own vector embeddings then, right?
Yeah.
Of words. And what dimension do they use? Is it 500 dimensional or 300 dimensional or?
It's 768, I think.
Okay.
Yeah.
So doesn't also Hugging Face do this? The same.
Yeah, the Hugging Face makes it easy to use all the different models, including BERT. It's just like a wrapper around the various embedding models, and then it adds architectures for particular tasks.
Yeah.
That's what, it's kind of like Fast AI for embeddings specifically, sort of.
Yeah. Yeah, it's a standardized, it just standardizes all these different models. So they've implemented quite a few. There's my rough understanding of what Hugging Face, but basically they're an interface, a standardized interface to them. But still, there are many, like each model is different enough that you really have to read the documentation and understand the model. And then again, that's what I mean, it raises questions. Like for instance, you can't simply assume because GPT-2 does this task, like but isn't suitable for the language generation because it's not a language model in the same way that GPT-2 is. So therefore the methods around them in the Hugging Face library are like different, I believe. And also it raises questions. For instance, when I've been looking at like this, I want to take something like BERT and use that to generate the embeddings. It seems to me that I should be able to do that with GPT-2 in Hugging Face as well, but there isn't any mention of this so far. Like, and stuff like that makes me ask questions in my own understanding.
Yeah.
Let me ask you about so you're doing sort of semantic extraction, right? Like on tweets. And so what do you do with it, with the semantics you extract? What's the business goal?
Well, at the moment, it's mostly driven to educate myself, but I think the most of it is to find, let's say, topics. So like when we did in the Fast AI course, you've got
like emerging. Do you mean like emerging topics? You want to keep an eye on sort of the evolution and trajectory of different topics that are being discussed overall in the whole corpus?
Yeah, I want to get an idea. I mean, it's not that implies like a evolution over time, and I'm not getting into that yet. That's okay. I think that would be the next level, right? But like, say we have this static set of things. We say we've got 10,000 or like 60,000 tweets, and they're around a theme. Now, if we go back to the Fast AI course when they mentioned topic modeling using NMF, you say, okay, I can, let's use NMF to do this. Well, that's one approach. The other one, I think, which I want to explore, is to take these word vectors, because that's still bag of words and it's TF, IDF. But let's go and take these embeddings, and then we can use dimensional reduction, and then I forgot. We've got k-means and everything else. What's the other one? Gaussian, whatever they're called.
Yeah, PSA, or what is it called?
Yeah.
Yeah, go ahead.
Yeah, so that's what I've been doing. I used that, and then been toying with UMAP, if you know that. That's another dimensional reduction approach, and it works quite well if you've got like very large data sets. So that's why I used it. And then I can share this like once I clean everything up, and then yeah, and then I use like a clustering algorithm, and then see how it looks, and it looks
You might like
so first
you might like LDA. You know, it's the classic way, latent Dietrich analysis for topic for topic modeling, right?
Yeah.
There's the whole area of topic modeling. It's been around before neural networks, and Jensen has it in there, and it's a classic way of seeing but they're kind of big topics. You know, they're bigger. So anyway.
Yeah, I did try that, and I think I mean, I'm just trying everything to get, because it's a lot of it is very subjective, right? I mean, you get a feel for it. So I used LDA, and then I used k-means. This was with word2vec and fast text, and then since then I used the UMAP just because it's much quicker, and it's. And then it's Gaussian mixtures, because the Gaussian mixtures allows for, well, it's very subjective, but I felt it could give me more flexibility in how the cluster shapes look. So k-means is like spherical, right? The clusters are all spherical, and Gaussian mixtures looked a bit nicer. But those are the lines that I've been thinking, and then from there it's just a question of, you know, are these clusters meaningful? Because I toyed around with NMF, and for the particular case I was looking at, I didn't feel that the outputs were particularly meaningful. Also, tweets are very interesting, because all of this stuff like BERT like trained on Wikipedia and books, right? So the quality of the input is quite high. And if you ever look at tweets, they're like, I don't think anybody like puts more than 3 seconds thought into actually typing these things out. The amount of typos is incredible. So what you find out is that fast text, which is like much more tolerant of, it's basically, it's a sort of, it's very character based. So fast text seems to be much more tolerant of stuff. So when you use word2vec, you have like a certain cluster shape, but it's because it leaves everything out that's like misspelled. And then when you use fast text, all this stuff just comes in, and you find all the clusters for, you know, like a huge amount of data gets pulled in because of all the misspellings.
What's fast text? Is that another word is that another embedding kind of a thing?
Yeah, it was, I think it's by Facebook, and it kind of makes sense because it comes from their domain, and it's tolerant to it's much more character level. So it can,
because Facebook tweets are Facebook posts are probably like tweets. Maybe they're a little bit better quality than tweets, but they're similar.
So the fast came out of, right, so like first thing was word2vec, okay? Yeah. And that was a token, like a whole word token base.
Yeah.
You know, you might do stemming before, or lemmatization, but then came Glove. I've been just whatever reading about this week a little bit. This may be obvious to a lot of people, but then came Glove, which was actually saying, hey, word2vec do this, we could use the old style. This is from the Stanford class.
That's right.
Just that video. It shows what Glove was take the old co-occurrence way of doing this stuff and implement it better. And so it's a co-occurrence base, doesn't even use neural network, Glove, but it actually performs better than word2vec in a lot of cases. And then fast text is an advancement on word2vec. It really does the same window stuff, you know, SIBO and whatever that is, and skipgram. You could choose between those, except it's now using sub-word grams. Okay, so you've got parts of words. I don't know, maybe it does letters instead. I don't know which one.
Characters.
But that's why you have more sensitivity and ability to get sparser words, right? To use and represent sparser language and so forth. But then this is where I've kind of stopped, but then this whole then Elmo came about, and along with BERT. And Elmo and BERT are these transformer sequence-based models.
Mhm.
And the interesting thing is that I don't think you can use BERT the same way you use Word2Vec in terms of finding like all the related words. You know how on Word2Vec, I don't know, Ray, you probably know you've used Word2Vec, right? You can say, give me the closest words, similar words to this one.
Yeah.
And you can also take out a word vector. But the problem is really, I think that particularly with BERT, it's a sequence, it's a seek-to-seek model. It's a sequence-based. So the words, it's really about the word in its context of each sentence. So it works really well for sentences and paragraphs and documents, but not, so I'm seeing there's sort of like these two sets of embeddings that have different affordances and used differently and have different histories of development. But I'd like to go further with that, right? Because just understanding the whole world of them is crazy. There's so many.
Yeah, that makes perfect sense. And actually, because that's a really good point to raise, because BERT is all about context, right? It's like it makes no sense to have it on its own. Whereas, so like my naive approach with tweets is just to take all the words that are in there and then take the average. And it really doesn't. I mean, that's like they're not independent of each other, and BERT doesn't. Yeah. So what I've seen is there's BERT sentence. There's like a BERT sentence method, I think, in Hugging Face somewhere, and I think that might be, or there's like various sentence level or sequence level methods, and I think that's the way. But I'm like still in like trying to get my head around everything mode. So
Ray, has anybody ever trained a language model on Twitter? In other words, take a standard language model that has been finely tuned on some multi-billion set of words, or like Wikipedia, and then fine tune it like Jeremy showed us how to do for a corpus of tweets, so that it would do well on tweets. I'm sure people have done that.
Yeah, I don't know, but I want to do it.
But I mean, that's the thing is, it's already, I bet you anything, it's already been done, and what you should do is start with that. Yeah.
There's something else as well on top of that. That's a lot of so Jeremy's method, the ULM fit method, really goes and says, you take all your data and you do the fine tuning, and then you do the classification later.
Yeah.
And it looks like, but it looks like the Hugging Face approach is you fine tune with the labels, if you know what I mean. Like you don't fine tune on unlabeled data. That's like if you follow all the tutorials. So my problem there is, I don't have a labeled data set. That's the difficult part. There are two difficult parts. One's grabbing the data, but that's relatively easy. And then having labeled data out of that, I would have to find a labeled data set.
Yeah, but first thing is just to build a language model which doesn't need labeled data. It's just to predict the next word. And you can imagine that a language model that's successful in predicting the next word in a Wikipedia article may need to be fine-tuned before it would be successful in predicting the next word in a Twitter post, post. So that's the kind of language you want to start with, a language model that understands Twitterese, let's say, so to speak. So you'd start with a Wikipedia language model and then use Jeremy's ULM fit method to fine-tune it for a Twitter corpus, and then you'd start with that.
Yeah. That's been my thinking. I think that what I'm trying to say is it's been hard to find someone who deviates from I haven't seen anything that works like that exactly.
I see.
But I'm still relatively early in my search for.
Yeah. Well, it sounds like a really interesting problem. So I wanted to ask you a question. How do you do the way I understand it from what you said is you do the dimensionality reduction first, and then you do the clustering. So is that how you work it?
Yeah, because yeah, from memory, yes, because it's been a while since I touched it. But I think I can't put the. I don't think it's the Gaussian mixtures. It can't work on the scale of like tens of thousands of tweets, so it needs to be dimensionally reduced, I believe.
I see. I see.
Yeah.
So
Oh,
what? Yeah. So go ahead.
Sure. Actually, maybe I'm wrong. Maybe I only do the dimensional reduction to plot it. Now that I'm thinking about it, I think I can get away with it. So I just push everything into the Gaussian mixtures,
Okay.
and then I literally just followed what the tutorial says on Scikit. So there's a method to give you, what's the optimal number of clusters, and then to visualize it, then I throw it into UMAP. And UMAP is, I was using TSNE before, but that's really slow. So just out of convenience, I switched over to this UMAP, which I read about somewhere, and it's a relatively new technique.
So how does UMAP decide how many dimensions to reduce it to?
Well, I need to reduce it to 2 dimensions to plot it. That's the main use.
Okay. Okay.
But UMAP itself doesn't do clustering, right? You need clustering on top of that.
I don't know, because the documentation is quite rich on UMAP. Actually, they say that because it does do dimensional reduction, they say there are ways of getting meaningful, applying that meaningfully. So, but I didn't know what that meant. So if you want to read through the documentation and understand it, then yeah, feel free. And because I wasn't really sure what they were claiming. Because they didn't really put anything substantial along with that. They just said if you want to use this for like some kind of clustering approach, you can do. So, but something like Gaussian mixtures is very well defined on what it does. So I just used that.
So how do you get, like, suppose you start with a tweet, right? How do you get the vector for that tweet? Do you do you add the vectors for each word in the tweet, and then that's the vector for the tweet? You add them, or you average them, or how do you do it?
Average them, yeah.
Average them.
Yeah.
Why not add them? Why not just add them?
Because I think you would end up with something where if they're various lengths, like some tweets, and also there's a lot of cleanup that goes into that. So like a lot of tweets have, which I haven't touched. So what I just made this big data frame, and I extracted the emojis, and then remove them from the original and extract their hashtags. And then what you end up with is some tweets don't have that much content other than, so I averaged them, and I guess I did think about adding them. I just went with average.
Okay, so when you average them, it would seem like they would average out to 0. I mean, they would average out to something very, it would seem to me that if you average all the words in a long tweet, let's say, I don't know how many tweets the words have, how many words the tweets have, maybe like 15 or 20 words, maybe. When you average them, they would be 0. They would average close to 0.
I'm not sure if they would work like that. It depends where they are in this like high dimensional space, right? So it's I think that's assuming you've averaged all the words in the corpus, right? I mean, if you averaged all the words in Word2Vec, maybe it would sum to 0. I don't know.
Yeah, I guess, okay, so a large number, so I'm thinking that if you take a large number of words and you average them, you're going to get close to 0. But tweets are not a large number of words. They're only like, 20 or 30 words. So, yeah, so maybe that's right. But I'd still think that adding them might be better.
It might be. I think it's just, I mean, I didn't discount it. I actually thought about adding them for a long time. Then I read around, actually, and people averaged them. And so I thought, well, I'll go. But who knows? I mean, we both thought about adding them as something that makes sense. So maybe that's something I should try. It's subjective in the end anyway.
Yeah,
really.
yeah. But I mean, do you actually get meaningful clusters? Like when you get a cluster, suppose you pull out a cluster, you do your k-means and you get a cluster, and then you go in and look at the tweets. Say you pull out like 5 or 6 tweets out of that cluster. Do they make sense that they should belong to a cluster?
I haven't evaluated it that closely, so I reckon so. Yeah, there are a few other things I want to try. But yeah, the one thing I did evaluate the most was NMF. I spent quite a long time on that, and NMF is like it didn't, not really. Like NMF is like there. It seems to center around like certain words, but they don't feel like meaningful topics. You know, so you end up with so NMF doesn't in that application didn't produce meaningful topics. It produced sort of themes, but the themes didn't have very little value in terms of like.
I want to wrap my head around how you use NMF, because what I remember from the Fast AI natural language processing course is that NMF is a method of factoring a matrix into 2 factors. So which matrix are you factoring when you do NMF in this problem?
I kind of cheated. I used a Spacey implementation of it.
Spacey?
Yeah. So because I wanted to get used to using Spacey as well, just because it's super useful. And there's an extension to it called Textasy.
Ecstasy. I like that.
Textasy.
I love it.
Yeah, Textasy is cool, kids, and it's got like a lot of it's a really nice add-on to Spacey. Actually, it's got a load of pre-processing methods in there, and it's like really useful for that. But it also it kind of like Spacey works on this sort of like individual doc level, right? And then
okay.
And what Textasy adds to it is like a corpus level view. You can build a corpus and do corpus level statistics. And one of the things that they put into that as well is is NMF out of the box with a nice visualization as well. So it becomes very, very easy to run it. And I actually used the Textasy pre-processing to clean the tweets originally anyway, elsewhere. Because
I think I remember how NMF gets used. You have something like you have a Word document matrix. You start with a Word document matrix, which has a row for each word and a column for each document, and each column contains the count of the word of that particular word in that document. So that's what the entries in that. It's an array with rows for the words and columns for the documents, and the entries are, for a given word and document is the number of times that word got used in that document, or something like TF-IDF transformation of that. So you start with this matrix, and then you can use NMF to factor it into 2. You pull it apart into 2 pieces, and that gives the embeddings for the words, and it also gives embeddings for the documents.
Yeah, so you end up with this, with the way the visualization. I mean, that's like a pretty perfect way of, you remember it better than I can. But the output from that is basically a very nice visualization of the topics, which you specify anyway, so it's arbitrary. If you want to say, I want 12 topics, it will produce them. And then it's the words associated, and then it's kind of like a rudimentary heat map on this particular view, but you get the topics and you get the words next to it and the relative distribution of those words per topic. So that's what it gives you, and then you can sort of play around with it, see how many topics you want to define, and then gauge the results, and from there. But then you just end up seeing like you can have words that have very little sort of the information value that you might think should be stop words, for instance.
Yeah.
And then they will define a topic. So then you have to go back and then add, I want to remove this word. So you add it to the stop word as a custom one and so on. So it requires quite a lot of tweaking to get something that you think works for your domain. That's my feeling on it.
So Spatie has its own way of embedding words. In other words, we're talking, now we have Word2Vec, we have Glub, we have, what's the other one that Darren was talking, Fast Text, and now you're saying, and BERT, and now you're saying Spatie also does its own version of Word2Vec. Then is that
it
right?
It wraps it like Transformers library, like Hugging Face.
Okay.
Yeah, you can access and use the various embedding models through Hugging Face, although they focus on the transformer models only, I think.
Yeah.
And then that's why their library is called Transformers.
Yeah.
Spatie wraps them, and actually you can also access some of them through Gensum and through Fast AI. So these are all just wrappers and ways of accessing and using.
Yeah.
Same
And the advantage of Spatie is it's just it's like something that you'd use to put things into production.
Fast, yeah.
It's fast and it's reliable, and it's like so even a lot of the stuff it wraps, they're very cautious about what they do, and they may only implement some of the functionality of these models just in whatever is like safe for production. So it's very opinionated on, and I guess in terms of what they implement. But it's good to be aware of, because if you're ever required to go and produce something for someone for production, you should just be aware that Spatie is the best way to do it.
Yep. So I think, there's going to be a lot of this, us just getting familiar with the breadth and depth, right, of this area of embeddings. And at the same time, we're sort of getting familiar with that. I guess maybe, the ultimate goal to some extent, I'm just suggesting this, this is the way I would think about it, is we end up with some data set, unique data set, and we start playing with some of these, whether you're doing it through Spatie or Hugging Face or whatever, just start each individually playing with getting something working on our data set, even without adapting the embedding, and then taking the next step. Well, how do you adapt, train it for the specific task or whatever on the, and then, like transfer learning stuff. But so another thing I was thinking, maybe we can get an update from Edgar on where he is with the human trafficking data set. Ray, you talked about a Twitter data set. I don't know if you have a unique one or you're just using one from the web, but we could talk about potential data sets if we want. Or another thing is that I was thinking I might, either through Sam, who I don't know, right, but Sam Sherrington, the TWIML guy, he's the one who's paid for these the Zoom meeting capabilities and stuff, and we're hosted on his platform for the stuff. But what I was thinking is either through him or randomly on LinkedIn, maybe I'll get a person to talk with us. Like maybe I'll get an expert who knows the breadth of embeddings. Well, in industry in general, maybe a consultant or something. These are sure, there's 20 embeddings out there, but only 8 of them are really used. And these 2 are usually used in this way, and these 3 in that way, so we could get like an overview of the affordances of the different embeddings. Or maybe we can get someone who has a particular interesting use case or something. So, I might try to do that. I don't know what people think of that.
I think it's a good idea. A lot of people would want to help as well. Has anyone ever spoken with anyone from Hugging Face, for instance? They seem very active on Twitter and very supportive. So
sure, maybe
we can say, look,
they'd be great. You're right. I didn't even think about that. I've heard them on podcasts, but I think if we do that, I'll do it for the bigger group. So like the NLP projects group.
Yep.
But it'll help us. But I think a bigger audience in that case is not too bad. I don't know. It would be better just to have them here, but it's kind of unfair to have someone come in.
And it seems like the Hugging Face library is already itself quite a good distillation of all the possible methods out there that are implemented, because also to my understanding the research on embeddings is just like exponentially growing, and everybody in every part of the world is coming up with their own embedding system. So then what I'm seeing is that Hugging Face is just taking almost like the main ones and then like making them accessible to the world.
Yeah.
So it's and then also I guess like the size is like a big big guidance there, because models just keep getting bigger and bigger and bigger. And one interesting thing in the Hugging Face library is the Stillbird, which then takes the bird and achieves like close to bird accuracy with like a fraction of the compute cost and parameters, which is quite interesting. And generally also on board going ahead with some project on this. So so to give a little background on where the modern slavery topic came up, is that I'm working with a foundation and an NGO who are just generally running research on this topic. So exactly on understanding how to eradicate slavery in the world. And then there's and then part of that project, it's come about that we want to create an open source data set on pulling all the modern slavery statements and running them through some like cleaning process, and then just making it available almost like an AWS open data set.
Nice.
And like AWS has like a lot of like, I think 140 different data sets that are available to mine and use, and some of them are text data. So we want to basically add that that data set in there too. And then over the next like couple of years, there's a plan of like mining those statements a little bit further. Now all of this has basically recently started in the whole project, and with all of these like NGO partners, I'm pretty much the only person at the moment who's writing any code. Or there's like maybe one more person or something. So what I'm thinking is that since this project is like early starts and I'm like extracting the statements, there's a possibility to then make this data available. It might be that that now we would then give access to like a single individual. So like if you're interested in almost like working on this, then give us your email and we'll give you access. And then as the project probably then would come to like a more solid ground, then this would be like open access to everybody. But what I'm estimating is that like, let's say I have like the first S3 bucket like with 10,000 documents in there collected. But they aren't like parsed, so they're like HTML and PDF files, right? So there's this process that needs to be done, and some more documents added to them. And I think maybe like if all I can talk to our project partners over a little bit, and then like maybe in a week or two, then everybody who's interested in, I would hope that I can then give access to that S3 bucket, and then it would be possible to work on that. So I don't know, how does that sound?
That sounds good, I think.
So we could sort of we could also help be your guinea pigs with the data. You know?
That I think there's like loads of research that is going to be happening on that, and I think it's in this sense it's quite interesting to be like almost in the beginning innings of that, and see where the different ideas would go on that and how they could be implemented, because there is also like some line that we have towards like policymakers to start giving like guidance on we have a line to like the UK Parliament, which we're hoping to use, that from this research we could give guidance on how companies should be like reporting on their practices, how this report should be made and then also like able to like do all that. So that's like, let's say, a couple of years down the line of thought, right?
Yeah.
Just to give some like further context.
It sounds like there's going to be a lot of document cleanup as well initially, which is always the case. So like to get the good quality data set, and yeah, it depends how old some of the PDFs are as well. And I don't know like how they're encoded. Sometimes you have to go to use OCR and so on. It might be, I actually think all of that is pretty interesting anyway. How do you tolerate stuff like that in your pipeline? So yeah, I think it'll be interesting.
Yeah, absolutely. And then I did play around with some Amazon and Google OCR tools, and they seem like quite good. So essentially my thinking is that all the PDFs I'm just gonna like send through the OCR API and get the TXTs back, and then and that would be then about 2/3 of the corpus, and then another 1/3 of the corpus is parsing HTML out.
Yeah. How expensive is that to use their APIs?
So it's well, yeah, I don't know now from the top of my head. Until now I've used like the free tiers. The free tiers have actually are quite taking it quite far.
There's a library called Tesseract. I know that's free, and people say it's very good. I think that's maintained by Google actually. Tesseract.
That's possible.
Yeah, it's worth looking at because I know that's free. I have and that's probably like a big consideration at some point.
Yeah, absolutely.
Ray, where did you say what Twitter data set are you utilizing? Or did you play with?
So to give you context, I'm working with another group. It's in the UK, and it's an academic group, and they look at the name of the group is the Algorithms for Marginalized People group. I can send you a link. And they have a project which has like some interest with the UK government, and it's to look at how politicians are affected by like the kind of messages, what people tweet, the kind of discourse that happens on social media to politicians in the UK. So they've started collecting data, but the team themselves are not they're not super code, like they're not coders really, or they're not in this space anyway. So I know them, and I've just started helping them out. So I have this collection, a sample of tweets from them, but I don't know if I can share it. I just know that I can use it. So that's one thing. And then, yeah, so that's what I've been doing. And I've just been trying these things out to see if I can get anything meaningful, and then just to double check what they're doing. So
maybe you can check if you could share. I don't know if you don't want to check, that's fine. But
I can check. I just want to be clear that the answer, the decision isn't with me. So
yeah, absolutely. I think Edgar, that's a great data set. The only thing I'm just thinking is we may need sort of two because we're waiting for the other one, the modern slavery or something. I don't know, but it would be nice to have just to have a data set to start at least doing some basic playing with. But yeah. So
yeah, absolutely. Yeah, I can come back like over the week and then like essentially just clear the space out with the partners that exist here, and then like let you know what's like, if they, I don't know if they would be setting any conditions or anything like that. I would hope not. At least that's where I'm pushing it. And then like, yeah, if that works, then like we can pick it up as a group, or else like anyone can join in or try out stuff. So it's all that is possible.
So I also have a data set if we need it. It's just it's all of Tech Target, who I work for. But Ray, are you a consultant?
Yeah.
Who do you work? Okay. So you're a data scientist consultant.
Yeah, I was working for a company based in the States for a while, and now I'm free. So hence I'm spending a lot of time looking at stuff and like just getting like right up to speed again.
So the company I work for, they create IT articles about different topics.
All right.
And a lot of IT professionals and companies read these articles. They're all online. We track their, activity on that and so forth. And then we hook them up with software vendors, so we see when projects are happening in different companies because they're reading our content. And so that content is all on the web anyway. So I can share. I have it in like a data frame, for example, a pandas data frame, or a JSON, which I have it in MongoDB and I export it into JSON. Not that we need it. It's kind of a boring data set compared to what you guys are talking about in a sense, but it's a little more traditional. It's news articles and feature articles, and all in a particular domain that is IT. So we kind of have 3 unique sets we could play with here. I guess we'll figure out over the next couple of weeks how to, like, if someone wants me to make it available, that let me know. Otherwise, I think we could wait for you guys to start.
There's one advantage.
I think that's very, very interesting. Yeah. Sorry. It's very. I think it's a great idea also to like go ahead on these lines, because what comes out of those this embedding research is that they are very data set dependent, right? And it will be interesting to see how much then they generalize in one context or another, right?
Yeah.
Do you think there's a place we could start storing these days? I guess we don't need to store them because, like, Edgar, you're going to put it in an S3 bucket that's available. Yeah. Maybe we just need to put them like that. Like, I'm a GCP guy, right? I've been doing Google. I work in Google in their cloud stuff. So maybe I'll just put it on my personal after this call. I'll just put it up there and give you guys a link to it in the buckets there. The Google Cloud Storage bucket. Yeah. And then, so if people are interested, they take a quick look at it or whatever. So we can start making and the other thing is if we could start writing some code of something, I mean, maybe I researched a little bit, and you can actually in GitHub create an organization. So I can go in there, I know how to do it now. And that's like, that's basically a Git repository for a group like us. And then we could try to start sharing code. It'll be interesting. Like, I know how to use Docker to some extent. I'm an expert, I've done it. But either through Colab notebooks or through Docker, we could maybe start learning how to share each other's little bits of code from what we're learning to apply transformers to our data, that sort of thing. So, and maybe that's a week or 2 down the road. I'm thinking a little too far ahead, but I don't think I'll create that Git repository yet unless someone's, really needs it for something yet. I could, but I don't want to create it and have it sitting there empty. It'll be demoralizing. I
was just going to go back to the data set that you say you have. And one thing that might be very good about it is it's probably very well defined. Like, I'm guessing if there are articles, there's probably topics there. And we can actually benchmark a lot of the stuff. Like, if we're, that's why yours might be really great, because if there are well-defined topics associated with them, then maybe, when we get the word embeddings, let's benchmark against those and see what's...
So the domains, so actually, right, so it's just text, right? But the domain is well-defined. However, I don't know if I can share this with you guys. I can tell you about it, but I don't know if I can share it. Basically, I was brought into TechTarget as a taxonomist. I'm a library school guy, taxonomies. I've been doing taxonomies for like 20 years. Yeah. And I came in and we built large taxonomies that cover the IT industry and products, IT products and companies. And we have 5 years worth of classified, very accurately, manually classified. These documents are classified to topics. So talking about benchmarks, you know what I mean? You could, each document has the categories with it and you can see what they are.
Oh, nice. Well,
I don't know if I can share that or if it becomes useful, but if it becomes useful, maybe I'll ask about it.
Because, I mean, even on your side, you could see, like, if we say we had a Colab script that took the embeddings and we clustered them somehow, and we have these arbitrary, very subjective clusters, it would be good to know if they, like, tally up with something that is meaningful and has been curated. And you can do that entirely on your own side if we can't see it. But that would be a very good way of imposing some objectivity onto this process.
Sure, that's a great idea.
And hopefully it might even help you. I don't know.
Yeah. So I really like that that your use case there, Ray, which is the semantic extraction or the topic modeling thing. You know, just extracting semantics from a corpus is what you're talking about.
Yeah.
And I like that. That's interesting, and I'm sure that it'll be interesting on all of our data sets, right? And I kind of have like a very clean benchmarked version of it, right?
Yep.
And then, you know, Edgar, you got this rich freeform version of stuff, and they're long documents. And then Ray, you got these, you know, the Twitter stuff is these short documents. So we got a pretty good.
Yeah.
So it's good. This will evolve. I guess my question might be, you know, this coming week, what do we want to focus on? Is it just another week of exploration, which is perfectly fine? Maybe that's exactly where we're at. Should we just do another week of freeform you know, exploration on our own, or is there something someone else suggests?
Personally, I think it works. I think like I've got a good understanding of where everyone is, and this is like really nice introduction. I would need a few more days at least, and I'll share like what I'm looking at continually, and I'll see what everyone where everyone gets to. I mean, that would work for me.
Yeah, same. I think also like there's a lot to cover, and then to like seeing where to find where to dive in. I like what I just find the general challenge is that there is like so incredible a lot of information out there, right? That it almost becomes like you all feel like this constant like opportunity cost that like that something that you're not focusing on, right? And
that's true.
And that's something interesting to train on my personal what I've seen.
Yeah. And personally, I think Colab works because I don't have a GPU on my machine, so
we don't need GPUs for a lot of this, though. But however, you can actually use single CPU. You go CPU mode with PyTorch and transformers. It's no problem. So it's good to play with the CPU version because we're not building big models. We're just either fine tuning them or just using the outputs from them. In fact, that article, Ray, you know, they talk about the BERT server. There's actually an open source BERT server, very easy to set up and use, super easy. And you just get sentence embeddings out of it. It's ridiculous, you know, but it's not fine tuned. Okay, so we'll do a week of freeform sharing. We'll get together next week, see where we are with the data sets, see what we've learned in general about this. I'll see if we can get maybe a speaker. I mean, who knows? I mean, I guess we'll just take it from there and try to keep moving forward bit by bit. Sound good?
Yep, sounds good.
Amazing.
Same time next week. We'll stick with this time unless anyone, are you guys okay with that? I know it's kind of nice for the European folks, right? Because it's later in the day, so I thought you guys might like that. So and Joseph and I work from home, so we can, you know, screw work for a little while. Okay, and maybe I'll post my set too. Okay, my data set.
Yeah. That'd be great.
Yeah, we'll watch for that.
Okay, we'll talk to all you guys tomorrow. I think we'll give them a brief update, the project team, and Stanford too, whoever's doing the Stanford course. So a lot of stuff going on. Jesus.
Yeah.
What's the call tomorrow? Just out of interest.
So the call tomorrow at 9:30 Pacific Standard Time, like 5:30 your time or something, whatever, at 9:30 PST. That's after the Stanford course, which Joseph is organizing, and I think Dinesh is the presenter tomorrow, and that's going through that Stanford NLP course. But directly after that Stanford NLP courses, which is from 8 to 9:30, we have the project course, and the project, or practical NLP, or the NLP_project. Okay, which is in Slack. That's the group we came out of. So that group, there's 3 different projects going on right now. We're one of them.
Yeah.
And each project's supposed to be meeting on their own and doing their own sharing and stuff. One of them is fundamentals, which isn't really projects, but they want to learn Word2Vec and understand it from the inside out and build their way up from the bottom up. And then the third one is summarization. I haven't heard much from them, but they're supposed to be working on summarization and all that. I mean, it'll all come at some point. It might all just come together, you know. So we might just end up with a project we're all working on. They may just jump in. Who knows? But that's what we have right now. So that's a general project meeting. So in that meeting tomorrow, we can give them an update of what we've done, what we're thinking about. We'll get updates from the other group. And we'll just see what happens. I mean, it's all really free form. Who knows what happens? It's going to happen.
Nice. Yeah.
Yeah. You haven't been in those, Ray?
No.
Okay. Right. So you came straight in from Slack, right?
Yeah.
And so you're welcome to it. Do you know where the invite is?
No, I don't actually. I'll grab it off.
Take a quick look at the group. If you need any help, let me know, or Joseph, and we'll set you straight there if you're interested in that. So,
cool.
Okay. I guess an hour is good enough for today, right, guys?
Yep.
Okay.
Thanks, Darren.
All right. Thanks.